Hi students, this is Alex here. In this video, we are going to solve the given equation dou u by dou t equal to alpha square into dou square u by dou x square subject to the condition. Let's write the suitable solution for this equation. So the suitable solution is u of x comma t is a cos px plus b sin px into e power minus alpha square p square t. And our first condition is u is finite as t tends to infinity. Then we have dou u by dou x is 0 for x is equal to 0 is the condition. So we need its derivative. So if I find derivative with respect to x, we do partial derivative with respect to x and t is treated as a constant. So this derivative is a into minus sin px into p plus b cos px into p, and this is a constant we keep as it is. Now this value 0 for x is 0. So the first condition is dou u by dou x is 0 if x equal to 0. So wherever x is there, we have to substitute 0, and that case this dou u by dou x is 0. So 0 equal to, here when I put 0, sin 0 is 0, so totally this term is 0. We have only b and cos 0 is 1, and we have p, and we have e power minus alpha square p square t. In this case, e power minus alpha square p square t is not possible to be 0, and p also not possible to be 0. Therefore, the only option is this constant b must be 0. So we take this constant b as 0. So by substituting 0 in our dou u by dou x, we are going to get dou u by dou x equal to a into minus sin px into p. So a into minus sin px into p, and b is 0, and e power minus alpha square p square t. Now we are going to use the second condition, that is dou u by dou x is 0 when x equal to L. That is the second condition which we take from here. Dou u by dou x is 0 when x is equal to L. So 0 equal to a into minus sin pl p e power minus alpha square p square t. And here already b was 0, so a definitely not possible to be 0. Since b 0, a cannot be 0. And p also not possible to be 0. And e power minus alpha square p square t exists for all the values of t, and this is not equal to 0. So the only option left is sin pl must be 0. That is, when sin theta is 0, theta is equal to n pi. So this pl equal to n pi and p equal to n pi by l. So we are going to substitute that in our solution. Here u of x comma t. So u of x comma t equal to a cos px. P is n pi by lx, and b was 0, so that term won't be there. E power minus alpha square, p square is n square pi square by l square into t. Thus we got the general solution u of x comma t as, we have to write a constant a naught, then summation n is 1 to infinity a n cos n pi by lx e power minus alpha square n square pi square by l square into t. And we have the another condition, u of x comma 0 is this function. So we are going to take u of x comma 0. Wherever t is there, we have to substitute 0. So t is present in the only place. So the rest of the terms a naught plus summation n is from 1 to infinity a n cos n pi by L x and e power 0 is 1. So we have only this much left, and u of x comma 0, it is x and L minus x for 0 to L by 2 and L by 2 to L. So here let's write it. This is x for 0 less than or equal to x less than or equal to L by 2 and L minus x for L by 2 less than or equal to x less than or equal to L. And this is a naught plus summation n is from 1 to infinity a n cos n pi by L x. This is the half range cosine series. So we state that this is half range Fourier cosine series. So we find a naught using the formula 2 by L integral 0 to L f of x dx. And as per the cosine formula, this a naught, what we have is a naught is a naught by 2 itself. So we can take this small a naught first, then we will find the capital A naught. So in Fourier cosine series, half range cosine series, we have a naught as this much, 2 by L interval 0 to L f of x dx. And this f of x is made up of two parts. So we are going to split this 2 by L integral 0 to L by 2, f of x is x. Then second part is again 2 by L integral L by 2 till L, L minus x into dx. Now when I integrate this, x integration is x square by 2. Our limit is from 0 to L by 2. And this is 2 by L. Its integration is Lx minus x square by 2, L by 2 till L. Let's substitute the upper limit, then minus lower limit. So 2 by L, when I substitute L by 2 here, it is L square by 4, and already there is one 2. So the 2 will be in the denominator. Lower limit is 0. Now 2 by L, when I put L here, L into L, L square, this is L square by 2, minus when I put lower limit, already L, then L by 2, minus L square by 4, and there is a 2, so it is L square by 8. So even this term, we could have written directly L square by 8, because already denominator 4 and there is a 2, so L square by 8. Now totally, it is possible to take 2 by L common. So this is L square by 8, and here L square minus L square by 2 is plus L square by 2, and this is L square by 2 with a minus sign, and this minus comes here as plus. So plus L square by 8. So we can cancel these two, and adding the like terms, we get 2 by L into 2L square by 8. We can cancel this 4 times, we can cancel this 2 times, we can cancel this. So this is L by 2. So we got A naught as L by 2. So this is the first part. And we have the constant an in the summation. This an is actually small an as per the Fourier series formula. So an equal to, again by formula 2 by L integral 0 to L f of x into cos n pi by L x dx. And now we have to split this into two parts, 2 by L. The first part is 0 to L by 2 and function is x, and we have cos n pi by L x dx, and we have second part 2 by L integral L by 2 till L, and f of x is L minus x into cos n pi by L x dx. And now we are going to use the Bernoulli's formula. So this part is u and this is v. U equal to x and v equal to cos n pi by L into x. So u dash is 1, u double dash is 0, and v1 is, this integration is sin n pi by L x by n pi by L, and v2 is minus cos n pi x by L by n pi by L whole square. In the same way, here this is u and this is v. So u is L minus x and v is cos n pi by L x. U dash is minus 1, u double dash is 0. v1 is, this integration is sin n pi by L x by n pi by L. v2 is minus cos n pi by L x by n pi by L whole square. Now Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So coming to an, outside we have 2 by L, then here it is u which is x, and v1 is cos n pi by L x by n pi by L. So here we have written cos n pi by, sin n pi by Lx by n pi by L. So this is sin. Then coming to the next term, minus u dash. So minus u dash is 1 and v2 is minus cos n pi by Lx by n pi by L whole square. We have 0 to L by 2 plus, again second part 2 by L, this is L minus x into sin n pi by Lx by n pi by L minus, and u dash is already minus 1, so we can make it as plus 1. Then v2 is minus cos n pi by Lx by n pi by L whole square. We have limit from L by 2 till L. Now let's take an equal to 2 by L, and we have to substitute the upper limit L by 2 for all these x. When I substitute for the first term, this is L by 2 into sin, when I put L by 2, LL gets cancelled, we get sin n pi by 2 by n pi by L. Then this will become plus after cancelling this. Then cos n pi by 2, by putting L by 2, LL gets cancelled, by n pi by L whole square. And when I put lower limit, because of this x it is 0, and here cos 0 will be 1. So 1 by n pi by L whole square. Then coming to second set of terms, we have plus 2 by L. When I put L here, and here, first term is 0 because L minus L, and second term minus cos n pi by n pi by L whole square, and minus, when I put the lower limit, L minus L by 2 is L by 2, here it is sin n pi by 2 by n pi by L, because LL gets cancelled, so n pi by 2, and here it is minus cos n pi by 2 by n pi by L whole square. So now we are going to take the 2 by L, which is common in both the terms. This 2 by L is common. So let's write the first term, L by 2 sin n pi by 2 by n pi by L. Second term, cos n pi by 2 by n pi by L whole square. Third term, minus 1 by n pi by L whole square. Fourth term, minus cos n pi by n pi by L whole square. This minus gets inside. So we get minus L by 2 sin n pi by 2 by n pi by L. Again, it comes here for the next term. So this will become plus now, plus cos n pi by 2 by n pi by L whole square. Now, here we can cancel L by 2 sin n pi by 2 by n pi by L minus L by 2 sin n pi by 2 by n pi by L, and then here we can combine the like terms. So here the like terms, only two terms are there, cos n pi by 2, here cos n pi by 2, so it becomes 2 times. So outside we have 2 by L, then this becomes 2 cos n pi by 2 by n pi by L whole square. Then we can write this one, minus 1 by n pi by L whole square. Then we can write this one, minus of minus 1 whole power n by n pi by L whole square. Cos n pi is minus 1. Now we can take the common denominator, that is 2 by L into n square pi square by L square. I can carry to the numerator here. Then rest of the terms, 2 cos n pi by 2 minus 1 minus of minus 1 whole power n is written as it is. L and this we can cancel. So we get 2 by n square pi square into 2 cos n pi by 2 minus 1 minus of minus 1 whole power n. So this is our an. Now substituting everything in our solution, u of x comma t is, we had a naught, but a naught is small a naught by 2. So we had small a naught is L by 2, but as per the formula, capital A naught is a naught by 2. So in place of capital A naught, we have to put a naught by 2, that is small a naught by 2. So already this is L by 2, then by 2 will come. Then plus summation n is from 1 to infinity. We had an, but an is this whole thing, 2 by n square pi square into 2 cos n pi by 2 minus 1 minus of minus 1 whole power n. Then we had cos n pi x by L into e power minus alpha square n square pi square by L square into t. And the constants can be taken outside the summation. So finally our solution is u of x comma t is, first term is L by 4. L by 2 by 2 is L by 4. And we can take 2 by pi square outside. Now we have summation n is from 1 to infinity, 1 by n square into 2 cos n pi by 2 minus 1 minus of minus 1 whole power n, then cos n pi x by L e power minus alpha square n square pi square by L square into t. And there is one L also here, because we cancel L and L square, so L is remaining. So we have to write 2L here, and that L also can be taken outside the summation. So this is the required solution for the given problem.